Hi everybody, in our next video we're going to start to factor quadratic trinomials where the a value is greater than 1. So remember, in a quadratic, in the general form, we talk about a being the coefficient of x squared. So if you notice, all the ones we're going to take a look at today have the a value greater than 1. So we have an a of 2, of 6, 4, and 8. So there is no shortcut for when a is greater than 1. The shortcuts are only applicable when a is equal to 1. So what we're going to do is start out the same way using this x method to organize our information. And I'm going to multiply a times c. 2 times 3 is 6. Down in the bottom, I write the b value, which is 5. I need to think of factors of 6 that add up to 5. And those would be 2 and 3, positive. What I do with these two numbers is, remember when we were double grouping, I attached a variable to each of them, and I broke up this middle term into the sum of these two terms. I'm also going to carry down the 2x squared and the plus 3 on the end. So now instead of 1, 2, 3 terms, I have 1, 2, 3, 4 terms. And we're going to factor by grouping. So we group the first two terms and the last two terms and decide what the GCF is. The first group has a GCF of 2x. And remember, we divide out that GCF from the first group, which would give us x plus 1. What's the GCF of the next group? That would be a 3. Remember, we divide out that GCF of the second group to figure out what we have left in parentheses, and that would also give us x plus 1. In double grouping, we're looking for these two binomials to be the same. That's going to be one part of your final answer. The second part comes from putting together the two terms in front of the parentheses. You could write these factors in either order. I'm going to move on to the next one. In the top of the x, I want to multiply a, which is 6, times 2, which would be 12. The b value, which is -7, goes in the bottom of the x. I need to think of factors of 12 that add up to -7. Well, I know 3 and 4 multiply to 12, but they add to +7, so both of these would have to be negative. A negative times a negative does give you a positive. So remember, we put a little x on the side of each of these, and we're going to break up this middle term into two terms. I'm going to copy down the first term and copy down the last term, and I'm going to factor by grouping. So what's the GCF of the first group? That would be a 3x. I'm going to divide out the 3x, so I would get 2x minus 1. What's the GCF of the second group? Well, because this is a minus, remember, I am going to stick the minus next. 4 and 2 both have a common factor of 2. So I want to divide out a -2 from everything in that second group, which will give me 2x minus 1. Common binomial, so I know that I factored out the GCFs correctly. That's part of my final answer. The second part comes from putting together the two terms in front of the parentheses. Continuing on to number 3. A times c, 4 times -5, gives us -20. The b value is technically a 1, +1. So the numbers I want to take a look at, the factors of -20 that add up to 1, I want to take a look at 4 and 5. But which one would have to be negative in order for me to get a sum of a positive 1? The smaller number would have to be negative. So again, I'm going to break up that b term into negative 4x and positive 5x, copying down the first term and the last term here and here. Now I have 4 terms instead of 3, so I'm going to factor by grouping. So what's the GCF of the first group? That would be a 4x. We're going to divide that 4x out from everything in the first group to give us x minus 1. What's the GCF of the next group? That would be a 5, so we're going to divide out a 5 from everything in that second group. We have a common binomial, so that's part of the answer. We put together the terms in front of the parentheses. That's the last part of our answer. For the last one, a times c, 8 times negative 6 would give us a negative 48. The b value is negative 13. So what are factors of negative 48 that add up to negative 13? Well, I might have factors 1 and 48, but if one of them is negative and the other one's positive, I'm either going to get 47, or if I flip the signs, negative 47, which is not this number. So I can't use that pair. What if I divide 48 by 2? One of them has to be negative, one of them has to be positive, but if I add those together, I'll either get 22, or if I flip the signs, negative 22. So that's not right either. What if we divide 48 by 3? Well, one of these would have to be negative and one of these would have to be positive. If I add them together, I get 13. Well, that's close. So what if I flip the signs? If I add 3 and negative 16, I will get negative 13. So what I'm going to do is take that middle term and break it up into negative 16x and positive 3x. I'm going to copy down the first term, copy down the last term, and I'm going to group. What's the GCF of the first group? That would be 8x. I'm going to divide that out from everything in the first group, giving me x minus 2. In the second group, what's the GCF? That's going to be a 3. We're going to divide that out from everything in the second group. We do indeed get a common binomial, so that's part of my answer. And the last part comes from putting together the 2 terms in front of the parentheses. So remember, when a is greater than 1, there is going to be no shortcut.